Wow, things are getting hairy here, right? Looking good. Now, we're going to use the same principles we used for exercise 7.8 here. So we've got our fundamental trig identities, these two, and their variations, and you've written that down without even thinking. That's your starting point. Then we're looking at our identity to go, we don't know this is equal, but this is what we need to prove. So we need to somehow show that the left-hand side we can manipulate to turn into the right-hand side, or vice versa. But we cannot just look at the equation. I just keep on stressing that don't write the equation out. Choose one side, simplify it, and it turns into the other side. Turns into from manipulation. We're going to choose in this case, I think almost without question, the left-hand side. Reason being, it looks a lot more complicated, so hopefully we can turn this complicated side into the much simpler right-hand side. So let's start with our left-hand side and then work through what are we going to do in each step and why. We've got two fractions here. So what do you feel like we should do here? Well, I'm of the opinion that we should write this as one single fraction. So if we can write this as one fraction, maybe we can simplify things and turn this denominator into sine x and the numerator into 1. We may need to do some things along the way to get there though. So let's go for it. If our lowest common denominator is 1 plus cos x sine x, then at some stage, maybe looking forward, we're going to need to create some sort of 1 plus cos x in the numerator, because then those will cancel. So let's see where we get to. 1 plus cos x is here, so we need to multiply this by sine x, so therefore we get sine squared x. Right? We've just written this first fraction as a fraction over this common denominator. Plus cos x, so we've still got that cos x. What do we still need to multiply it by? Well, we still need to multiply it by 1 plus cos x. Oh, come on. 1 plus cos x. Okay, right, so all we've done is we've taken the left-hand side and written it over a common denominator. Now it looks like there's some simplifying we can do. I'm going to leave the denominator as it is. 1 plus cos x, I don't want to multiply it out because we've got a sine x, so hopefully things are just going to cancel. Sine squared x, well, let's leave that as sine squared x, and let's multiply this into the bracket. Plus cos x plus, what we have, cos times cos squared x. Now something's staring us in the face here, isn't it? Sine squared x plus cos squared x. Notice that now in these examples, it's not that they're sitting right next to each other, but this identity here, sine squared x plus cos squared x, oh look, sine squared x plus cos squared x. But not staring at us in the face, now the terms are separate. So let's say, well, that's fine. We know sine squared x plus cos squared x is just 1. So I'm going to write that bit is just 1. And then we still need to add that cos x. This is equal. And the denominator is 1 plus cos x sine x. Now this is 2 terms over 1 term, so we can't cancel. But sneaky way, how do we turn something into 1 term? Yeah, factorize or just put in brackets. Hey, look at that. We can cancel that entire bracket with that entire bracket. That equals sine x, it equals 1 over sine x, which is our right-hand side. So we're done, yeah. But just to review, we took the left-hand side because it was more complicated. We thought, well, this is just 1 term on the right-hand side, but even if it wasn't, then let's just turn this into 1 term, 1 common fraction, and things kind of just flowed from there.